Okay, guys, so let me go through your independent asynchronous work and I will tell you what you need to do. So you just talked about popcorn. You thought about popcorn. Why does it pop? What's going on? What can we see when we just look at popcorn that could help us figure out what's going on at the microscopic, the chemical level? That's what we're thinking about as chemists. What is happening to the particles that is causing the popcorn to pop? That's what we're doing. So what I'm going to do is show you how to do your popcorn model. It's on the next slide. I want you to make sure you're writing complete sentences, please. And know this. This is what we call an initial model. You did these last year. There's no right answer here. We don't expect you to know everything. It's okay if you know nothing, for sure. That's cool. In the next 2 weeks, you're going to learn things and you're going to come back and you're going to change what you already thought you knew and you're going to go, oh, and you're going to change something, or you're going to go, oh, I was right about this, but I was wrong about that. All of that's okay. That's what scientists do. They have a model in their mind, or they make a model on a computer or on paper, and as they learn, they go, oh, that model is not 100% correct. What's different is this, or I need to add this to it. Okay, so that's all right. Remember, while you're modeling today, think about how big your particles are, how far apart they are, how are they moving, what state are they in? Are they solid, liquid, or gas? And does my model actually explain why does the kernel pop? Does popcorn pop? That's what we're trying to explain, okay? So here's what our model looks like. And by the way, all those questions are down here. If you kind of there's like 3 little dots here. If you put your little hand here and drag it, you can see those questions, the same questions about to remember when you're modeling. So let me see how I can move my face out of the way. Here we go. So what we have here is a before and an after. Okay, I'm giving you the before. Don't change this. I'm telling you that these are what the particles look like before. This is based off of what we talked about for our do now. A lot of you told me we think it's solid particles because we can bite into popcorn and it hurts our teeth. So they're solid. So this is what solid particles look like. They're close together. They're vibrating in place. Let me fix this one. This guy. They're vibrating, which is what these little lines right here look like. They're like vibrating in place. They're not moving all around. I know that because I can touch my head, which is solid, and my finger doesn't go through my head, luckily. But it does go through water, right? My finger will go through water. And that's because when you push a liquid, molecules move because molecules are always kind of moving around. But solids, don't tap it on my computer. And so this popcorn, you can't just hook your finger through it. The particles are really close together and they're not moving around. They're kind of stuck, but they are moving. They do have energy, okay? So I want you to write for me about what the particles are like here. And then the hard part, the interesting part. I want you to look over here on this side. This is the during. This is the right before the popcorn pops. Whatever you're doing, you put it in the microwave. You put it on the stove top. On the video, they have it like over a little heater or a burner, right? It's just on a little thing. Whatever's happening to that popcorn in this picture over here, it's just about to pop. The instant in time right before it pops. I want to know what's happening to those particles. Why does popcorn pop? There's some chemistry, some physics happening here, okay? We want to figure this out. So I want you to write. This is the part that you might not know, and that's cool. I want you to think about it and do the best you can. What are the particles like right before the popcorn pops? Tell me about that. Then I want you actually to figure out how you can, once you have an idea, like how can you show that idea with pictures? And this is hard, and we will talk about this in class. But again, things that are hard, you need to practice. So do it now, and then we'll learn, and we'll get better at it. So what I want you to do is I made this little particle bank for you. It's kind of a pinky yellow. I can't tell what color that is. It's called a particle bank. I want you to take things out of there and put them in the circle. Don't think you need to take all of them. But if you're using none of them, I'm not sure exactly what you're doing, okay? Remember, you're drawing the particles inside the kernel right before it pops. Here's where it's cold. Here's where right before it pops. So maybe you want to use these particles. You're going to drag them over. Maybe you're like, no, not those. I want bigger ones. Maybe I think particles are bigger now. So you want some big ones. I don't know. Maybe you're like, but the particles are different. They're not the same. Something changed. So maybe one way you could show that they've changed is by changing the color. I use blue, but click on this, make it red, make it pink, whatever you want. Maybe you want to show that they're moving, and maybe you not. Maybe if you want to show them vibrating, you can always just copy and paste or drag these over there to show them vibrating. Now this one's vibrating. See, look, it's vibrating. But if you want to show them moving, maybe you want to show a particle and an arrow. Maybe you want to use long arrows. Maybe you want to use short arrows. Maybe you don't want arrows to all point the same direction. So drag the arrow and make it long, make it short. You can change the arrows is what I'm trying to tell you. You can even change how fat they are if you want fatter arrows. Here, I'll show you. You can change the color. I want red arrows and I want really fat red arrows. Or I said fat, Mr. Murphy. Yeah, like that. I want big long arrows. Although this one's not going to fit in there. But anyway, you can do a lot with Google Slides. You can modeling on Google Slides. It's pretty nice. There's a lot of things you can do to show what you want. You just have to kind of get good at it. So you got to practice a lot until you get good at it. That's how it works. That's what we're going to do. That's the big thing for right now. What's happening to make popcorn pop? You did your observations. You did your inferences. Now we're modeling. Okay. In class on Friday, we're going to look at some of our models and see what we think. Okay. Moving on with our lessons today. Here. So we have some vocabulary work as the rest of it, because I don't think this will take you 20 minutes or so, and we want some more. So this unit, there's so much important vocabulary that we need to practice. So the next pink slides are words we've already used in class. Read them over and then do the practice, and I'll show you what that means. So here, matter, get out of the way, Mr. Murphy, sorry, is the stuff that makes up the universe. Look at the picture. Here are particles. These are nouns, a tiny piece of something, states of matter, observations, inference. You can read these. I'm not going to read them to you right now. Here is what you need to do to practice. You're going to take the word and you're going to match it. You're going to put it in the box. Here, maybe this one goes here. And is a tiny piece of something an inference? No, that's not right. Okay, so don't put it there. Bring it back. So I want you to match them. Here's the definition, match the word. That means you got to read the definition, think about it, and then match the word in the right place, okay? So now here are some new vocabulary, and these can be tricksy, so be careful, okay? That's why it's worth thinking about them now. Even if you don't learn them 100% now, it's okay. We'll do some more practice. So the green words have new words. The green slides have new words. Read them to yourself. Then try to answer the questions at the very bottom of the slideshow, down here, okay? So we have energy, the ability to make something move or change. Kinetic energy, energy that comes from an object in motion. So a car moving has kinetic energy. Thermal energy, the energy an object has because of the movement of its particles. When you heat something, you're adding thermal energy. You're making the particles go faster. Cool. Temperature, the average kinetic energy of particles. So when you feel something is cold, that means there's not a lot of kinetic energy those particles have on average. Some might have a lot, some have tiny, but the average is pretty small. When something's really hot, ow, ooh, it burns you. That's because the energy went from the hot thing, from that iron that you put your finger on, into your finger. And the energy moved. There's a lot of energy on average in those particles. Okay, so here's a cool thing. Here's an extra hint to think about the difference between thermal and kinetic energy, to differentiate between them. The kinetic energy of a particle is how fast it's going. Think of this as the arrow attached to a particle. So here's a particle with an arrow. That's how fast it's going. You can kind of show like a long arrow being fast and a short arrow being slow. To find the thermal energy of the water, remember that it's like the total kinetic energy of all the particles. Think about adding all those arrows together. So this is one particle, the thermal energy of all of the water, add up all of these arrows. So the thermal energy is a lot more. Think about this as like 1, 2, 3, 4, 5, 6, 7, 8, 9 arrows worth of energy versus only one. So in which state of matter, particles in which state of matter have the most kinetic energy? I wrote this. You'd think I should be able to read it. Solid, liquid, or gas. Which particles have the most kinetic energy? You're going to write the word in here. I think the particles in the have the most kinetic energy because why? Is there more thermal energy in A or B? Why? I think there's more thermal energy in because. Which has more thermal energy, cup A or cup B? Why? A or B and why? What about this one? Drag the correct label. So you got the this is a huge iceberg. Think about like there's a little boat, or there's a really big boat, and it's this big. This thing is huge. This is a little tiny cup of coffee. Which one has more thermal energy? You're gonna drag it. Is it this one? Is it those? Make sure they show up on top. Or is the more thermal energy over here? I don't know. You decide. Making sure again that this works for you guys. I should have tested that out. Okay, so which one has a higher temperature, which is lower temperature, which is less thermal energy? You're just going to add one to each side. Okay, that's it. We will go over these on Friday. That way, I want you to try now. And then on Friday, you go, yes, I was right. High fiving yourself in your living room. Or you're like, darn it, I missed it, but no one knows. So it's okay. And now you learned it. So next time you're going to get it right when it counts. Yes. That's it, guys. That's science work for the day. I'm done annoying you. Goodbye.